So let us show one of the examples next. So, for example, Ideal Star developed an extremely high sensitive oxygen sensor using a flaring. So at the moment, advanced semiconductor devices are approaching the size of 1 nanometer, just the same as a flaring. But the interest of semiconductor processing technology at the moment is required very pure gas delivery system to process the semiconductor technology. The figure shows one of the gas delivery systems used in the semiconductor processing system. So at the moment, gas sensor, especially the residual gas of oxygen and vapor is necessary to detect the accurate. So at the moment, the gas sensor is accommodated only main gas reservoirs, the left-hand side of this figure, and there are no sensors equipped in each use stop illustrated in the right-hand side. So gas sensors using fluorine has an extremely high sensitivity, as I said just before. The reason of such a high sensitivity is that the size of the fluorine field is formed from the roundabout nanometer scale, but the spacing between each fluorine has enough large space to occupy the oxygen molecules or atom. This fluorine field absorbs the oxygen, change drastically their electrical conductance, which enables to detect the oxygen content. On the other hand, in organic material like the silicon is of course absorbs the oxygen, but the oxygen is only absorbed on the surface, not inside the bulky material. So conductance change is limited. This is one of the experimental results. The conductance change is listed as a function of oxygen content in nitrogen gases. You can see nearly several percent of change is clearly observed as the oxygen content of 10 parts per billion. We can expect 1 part per billion of the oxygen content is detected by using a fluorine sensor. And the sensor is a very simple structure because we can only detect the resistance change by the oxygen absorption. And of course, the sensor is small and economical. These sensors may be applicable to all over use point in the gas reservoir, gas processing system. At the moment, as I said before, the gas sensor, high sensitive gas sensor is also accommodated on this gas delivery system. But the system is very, very expensive. So, as I said before, the sensor is only accommodated on the main gas reserve. We need to use all of the use points, the sensors. So these Flaaren applications may be applicable to such a use. Next interest is of course end-heterological Flaaren, which has an atom inside the carbon case. Ideal stars succeeded to synthesize such a very unique material effectively. Especially, we succeeded to insert the lithium atoms inside the carbon case. As you can see, alkali atoms are very, very active. They react another atom or combine themselves to form a metal. It's impossible to realize a single alkali atom. However, by inserting such active atoms in carbon case, it became possible to use this alkali atoms, singular alkali atom. It's really exciting. And also, these physical and chemical properties also affected by the atoms inside the carbon case. For example, the figure shows a schematic view of the synthesis apparatus of lithium Flaaren. Fundamentally, the lithium Flaaren is synthesized by low energy ion implantation. Here, the lithium ion is coming from the left-hand side to right-hand side. And also, the Flaaren is also supplied simultaneously with lithium ions on the metal substrate and synthesize lithium Flaaren. This is one of the results. This is a laser desorption mass spectrum of the product. The center of the spectrum, that is 727, is lithium Flaaren, lithium end-heteral Flaaren, because the mass number of Flaaren, the carbon 60, is mass number of carbon 12 times 60, that is 720, and plus lithium atom of 7, so that is 7 to 7 is end-heteral lithium Flaaren. So you can see that clearly we can expect lithium is inserted inside the carbon case. It may be a first time to observe this spectrum. And of course, the application of this unique material is interesting. For example, this is a photo emission spectrum. You can see left side shows the emission spectrum of end-heteral lithium Flaaren, and blue is empty carbon 60. You can see 1 electron volt of H energy is lower compared with the energy of carbon 60. These characteristics is very, very important for